In this case, we're looking at a simple L antenna with a ground plane. We're going to put in a matching network, look at a couple of these inductors and capacitors and FDTD blocks as far as components go. We'll look at design goals and how those are used, and then also the tuning sliders, so that way you can see just how that feature works. And then we'll apply this back to the FDTD simulation where we can look at realized gain. So let me switch over here and pull up this example. This is the XF user interface. For those of you that are not familiar with it, we have a CAD-based front end where you can manipulate your 3D geometry, assign circuit components, request results, define your materials, etc. And this is the full wave, traditionally the full wave user interface where we run the FDTD simulations. We've also added a schematics branch down here within the project tree, and this allows you to edit the schematic editor. And so we have an integrate within a single product where you can run both the frequency domain schematic editor alongside your full wave simulation and results. And so that just eases a little bit of the workflow in terms of doing this matching network design. So for this example, we have a simple L antenna, across the top. We've got a large ground plane across the bottom. And if I zoom in here, you can see a circuit component just connecting the two. We've run an FDTD simulation. You got the full wave results. That'll allow us to look at the far zone radiation patterns. That'll also allow us to look at the unmatched S11 results. So here, we're interested in roughly the 830 to 880 megahertz band shaded in blue. And as you can see, we don't have a very good match like it is. And so we're going to want to out a schematic to match it. So I'm going to right click on the schematics. I'm going to create a new schematic. I'm going to go ahead and open that. And this is what our schematic editor looks like. It's a window, can be moved around, but we'll just leave it maximized for now. For those of you that are familiar with, like ADS, or those are very broad tools that support a lot of applications. And we've really just kind of like stripped out the features that are needed. So you have your voltage sources, a resistor, you've got lossy inductors, capacitors, switches, phase, an SMP block. So if you're working with a component manufacturer and they're providing you measured component values and performance, you can import those as an SMP file. We've got an FDTD block, which allows you to bring in the results from your full wave simulation directly into the schematic. There's a couple of voltmeters and amp meters, and then there's a sub-circuit tool and terminal tools, and then a handful of like microstrip based transmission lines that are available to you. So I'm just going to start out by creating a simple matching network just to show you kind of like how this is built out, just a little bit of these. So we'll click on a voltage source, go ahead and place this for port 1, place another one over here for port 2. I can select a capacitor, hit the R key on the keyboard just to rotate it. I'll place that capacitor, and then I'll grab one of these inductors, place a couple more of them, rotate it. Now that all my components are here, I can press the wire tool or the W key to go ahead and enable the wires. I can connect all these up. And finally, the G key, and I can place the ground. So there we go. The schematic is built. In this case, we're just like, well, maybe we're going to treat this antenna as an ideal, well-defined, well-designed 50 ohm load. And so does this matching network, provide what we need for a 50 ohm load? We can run the schematic, and it's a schematic editor, or it's a frequency domain circuit solver, so it runs very quickly. We can go to the results tab. These are the results that are available for that simple schematic. And these are pretty much all of the results that are available. Whenever we add an FDTD block, there'll be a couple more results that appear, such as delivered power and system efficiency or radiation efficiency. But these are the standard results you would get from a frequency domain circuit solver.